Our real goal for today and kind of where we started last time was thinking about these principles of how we learn, how we can use them to design and implement effective learning experiences. Last time we talked a little bit about some of the principles of how we learn, how the way we learn things best really depends on a whole bunch of different factors. We're also going to maintain our no jargon zone too. So let me know if I'm saying something that is not a common term and we'll go over that. Some of the key things we talked about last time was, the same strategy or technique is not going to always work for everyone, right? At all times. So we're never going to have a one size fits all solution to any educational need. And as we develop expertise, what we needed as a novice, we don't need so much as an expert. So again, the same strategy or technique that was applicable at the beginning of the journey is not going to be as applicable as we move forward. And we talked a little bit about that last time too. So just again, thinking about, we can't have really any sort of rigid thinking when it comes to these topics, because we really need to be always thinking about the learner, how they're interacting with the learning environment and whatever it is that they're learning. What is their prior knowledge? What is their current level of expertise? And all sorts of other things that can be going on that we'll talk a little bit more about today. And we did a little experiment last time, or a little exercise that really, helps us to see that, learning is hard work. And sometimes we can think that we know things, or we think things are easier than they actually are, because they look so easy. And Sandy, last time we did an exercise where we all tried to draw this hand after watching a video that makes it look incredibly easy, and it is not as easy as it looks. And we had a little chat about watching instructional videos, and do they make you better at something? And again, it's a lot easier to see someone doing something than it is to actually do it yourself. And we can sometimes sort of trick ourselves into thinking that we know things just because we have a familiarity or a sort of fluidity of recognition. So a take-home message from that section was, learning was hard, right? And it's really important when we think about student learning and any learning environment that, we don't want to do people a disservice by making it seem like, learning stuff is easy, right? Because learning anything and developing any kind of expertise is difficult, does take a lot of effort. And it's important that we acknowledge and understand that. We talked a little bit about, again, this sort of making sure that we are not falling prey to this idea of learning styles that lots of people like to talk about, but really that when we are teaching people things, we need to be matching the mode of instruction, right, with the content and what we're trying to learn, right? So if we're trying to teach somebody how to change a tire on a car, if they don't know anything about that, then we ought to show them a video or show them a demonstration first. But if they already know how to do it and we're just tweaking some element of it, then we might not need that. So really the actual thing and actual content that you're teaching is what is going to drive the best modality, as well as the interaction with the person, versus telling somebody that they can only learn something in a certain way. And I think we talked a little bit about how if we do that, we run the risk of sort of squashing that growth mindset, right? And making people feel like, oh, I'm not a math person, or I can't learn that, right? Like everybody can learn things, but it just takes effort. So really, it's just a quick spin around this part. We talked about how we take insights from the fields of psychology, from cognitive science, all sorts of different topics that can help us inform the design of our learning experiences. So when we think about the work that I do and this whole idea of learning engineering, we're really using evidence of how people learn to help design better learning experiences and environments. But we need to know how to do that in different contexts. And we, again, talked about this last time, but when you think about someone building a bridge, such as this lovely one here in Northern California, we can have a physicist who really has a deep understanding of physical principles. But if you're actually going to engineer and build a bridge like this, or like that one I was just talking about that melted, what are some of those practical questions that you need to ask, right? There's wind, there's friction, there's weather, there's temperature, there's all sorts of things that are going to influence how I'm going to apply these physical principles that I know, right? So it's kind of bringing those two pieces together, which is really what the whole idea of learning engineering is all about. So how does learning happen? That's the learning science part. And then how can we create and adapt environments that support learning? And a key thing, when we're thinking about technology and learning is we have to always be mindful of the learning comes first, right? And the way that it's being implemented should be the secondary part. So we don't want to just create some snazzy, jazzy, shiny, technology-based learning experience and sort of, throw out the window all of the things that we know about good teaching and learning, right? So if we're actually going to do that, we need to make sure that it's not about the technology, but it's about how we're actually using it. And we talked a little bit about this too, how our minds work. And I'm just really, for Sandy's benefit, just a quick spin through this, but that we have information that comes into our brain, we connect it to our working memory, and that's the part of our brain that kind of handles stuff that's coming in, handles new information, and it collaborates really nicely with our long-term memory. And once we have sort of developed knowledge that moves from our working memory into our long-term memory, then we can kind of access it, and we have this kind of nice communication between the two things. But we have to actually do stuff, which is what we're going to talk about today, to get things from our working memory into our long-term memory, so we can free up some space in our working memory to learn more stuff, right? And that's how we build up automaticity, and that's what learning is. And we showed this last time too, just this kind of it's quite overwhelming, but really what I'm trying to illustrate here is that, there's all sorts of different things that are going to impact the sort of this middle kind of thread of this learning journey that we have our sensory memory, our paying attention to things, working memory, long-term memory, all the kind of pieces around it, which aren't meant to be digested at once, but are all things that we need to think about or things that are influencing this pathway. And we can, again, use what we know about people, how people learn, to design these experiences and help students be better learners. This is where we got to the last time. So we know a lot about how learning and expertise works, but sometimes things can get in the way of that. And again, thinking about our bridge designer and our bridge engineer, we might have a really nice bridge that we could build in a lab. All of a sudden we put that bridge in the real world, and there's all kinds of other stuff that that comes into play that we need to consider. Otherwise our bridge is going to kind of melt or collapse or something else. So we really need to yeah.
I wanted to ask you if you've got that diagram, that complicated diagram you showed again. Have you ever, you passed that one.
Yep.
Have you ever read Daniel Kahneman's Thinking Fast and Slow?
Yep.
Oh, that was one of the best books I've read in the last decade.
Yeah, it's awesome. And actually, I'm going to talk about something that's very related to that in just a second. Yeah.
Ah, okay.
Yeah. No, it's great. Yeah.
If there's any brain or cognitive science geeks out in there, that it's a big, thick book, but I couldn't put it down.
Yeah. And that book is really great because it really talks about how we have these sort of different systems in our brain, and at certain points things some things can sort of take over, right? Sort of these two different systems. Actually, we're going to talk exactly about that in a second. So
excellent.
We'll get to that. But so when we think about this whole design idea, right? It doesn't really matter how good your learning environment is if people aren't motivated to even start and persist and put in effort, right? So those are the things that you really need, these kind of motivational actions to get learning to occur. But there are things that are in this box here, right, that can get in the way of that. And I feel like Tim is like setting me up. It's perfect. So we're going to look at a study here. And this is a study that actually Kahneman talks about in one of his books, right? So you don't say anything about this, Tim, if you already know the results of this study. But I just want to use this as an example of things that can influence our cognition and our cognitive processes in ways that you may not think about. So this is a study that some folks did on parole board decisions, right? So all of these rulings of this parole board were evaluated across 4 different prisons, and the parole boards consist of these people here. And the researchers were interested in what factors influence the likelihood of being paroled. So it could have been, the prisoner's sex, the ethnicity of the prisoner, the severity of the crime, maybe it was a fraud versus an assault, maybe the amount of time that had already been served. And so they looked at all these different parole board decisions. They spend a whole day looking at these applications. The cases are presented randomly, so there's no pattern in how they're presented. And they spend about 6 minutes per case. And the default decision of these this parole board is to deny, right? So 65% of the time the decision is denied, 35% of the time it's approved. And that's sort of the sort of historic data, the patterns that occur. And you can imagine that, there's a risk, right, to approving parole. So you can imagine that people might err on the side of denying it. So in this particular study, they recorded the time that the decisions were made. And so given that the y-axis there shows the proportion of time that parole was granted, right? So what would you imagine the graph should look like if that pattern sort of maintained across the day?
I don't remember exactly what it was, but and how the graph was, but it had something to do with the breaks, I think. Whether they are actually being fit to make a decision or not. But I don't remember now whether they would deny it more closer to the break or whether they would approve it more closer to the break. But something with the breaks, that's what I remember about it.
Okay, so yeah, and we'll get to that in a second, but you're exactly right. But so if you were only looking at this information, we'd probably expect there to be a kind of pretty straight line across here, right? That if this is approval, so we think of, okay, about 35% approval across here.
Oh yeah.
So what we see is this pattern. So we have kind of this denial, or more people are being approved, at this point. And then we have the amount of approval gradually decreasing to here. And guess what's happening here?
Break.
Whoops, morning break, right. And then they come back from the morning break and we see kind of the same thing, right? Now they get to have their lunch or whatever, and now they come back, right? And so we have this, this group of judges who are getting, hungrier and hungrier and hungrier. And what we can see here is that, if we think about the default decision being the easiest one, right? So if denial is the lowest risk decision, right? So you're not going to make a kind of wrong decision and let someone go when you shouldn't have. So it's a sort of an easier fallback to have a denial. That going against that requires more cognitive effort, right? So if you're approving more paroles, then you're sort of having to think a bit more carefully, think a bit more purposefully about that. And what you see here is that as the sort of time before the breaks, as they get kind of hungrier and tireder, they start to, fall back to that easier, more cognitively easier default position, right? Until they get to here, and then they kind of come back up, right? So, and I only bring this up to illustrate that, other factors, right, can play a huge role in our cognition and the amount of effort that we're willing sometimes to put into something, but it's not always about the learning itself, right? There may be other things that can come into play and can affect that. So if you're on the parole board, or if you're getting paroled, I guess you want your case to be seen here, right? Right after lunch. But, I think you can think about ways that has applicability to all sorts of training environments too. And, we all know that, there's sort of diminishing returns as we have to pay attention to something for a longer period of time. Which brings us back here to this, what's Julia, the best way to, yeah.
Sorry, Julia, I just found it also interesting to see that when you go back to the slide, to the graph, I think it's very interesting to see also that after the first break, the decision time already falls quite quickly. And it's up a little bit again. But when you look at the last break, it just goes really down straight. So over the course of the day, I think that was a really interesting one there as well.
Yeah. And again, you may have sort of like, in a way, you've got these two factors, right? You've got time and you've got, hunger as well, right? So maybe at the earlier point of the day, the biggest factor is maybe you're hungry, but now as you get to the end of the day, now you're tired and hungry or something, you know, so it's having an even bigger impact. Yeah.
Yeah. Cool. Thanks.
So again, you know, when we think about this, you know, what's the best way to do something? There's always going to be things like this, right? Like, okay, well, what time of day is it? Is this person hungry? Are there other things going on that's going to influence how well somebody is able to learn something, or how much cognitive effort, because we know it's difficult, that they can actually apply to something. So when we think about learning, right, we could think, you know, we could see problems with, you know, how much someone values something. So, you know, if you're a student and you just don't see the point in something, then it's going to be difficult for you to, again, like have that motivation to, you know, even engage and enter into something. You may have a student who has issues with self-efficacy, right? You may have a student who says, you know what, like, I can't do this. This is, and this goes back to that, you know, growth mindset, learning style myth that, you know, if you think to yourself that you're only a visual learner or something, then it's going to be very difficult for you to engage in something that isn't a visual kind of medium, because you may think, well, I just can't do that. You may also see that, you know, things are in your way. Sorry, now one of my sons is printing something. But you may see something is in your way, right? So you may think that, okay, my teacher doesn't like me. This textbook is boring. I don't like the way this book is written, and a whole bunch of things like that. Or you may be in some other type of state, right? You may be angry or depressed or hungry or scared or all sorts of things. And as an educator, it can be really difficult, right, to know, like, well, which of these things is happening with my learners, right? And diagnosing and treating these things is all going to be part of how we design and implement different learning activities. So if you think about a question like this, right, this is a genetics problem that my husband wrote, but you may have two students who may both appear, you know, equally disinterested and unengaged in this problem. Superficially, they could look the same. The affect may be the same, but they may be completely different sort of cognitive and motivational experiences going on with them, right? So you may have one student's like, oh, I hate this kind of problem. It always has too much math. I can't do math. I don't want to do it. You have another person that's like, you know what, like, why should I care about this? I'm not going to be a scientist. And so the way as an educator that you would approach, you know, both of these students would be very different, right? For the one student, you might have to help them see, like, you know, help them step through some of the math with a worked example or something like that. Or you may help them to see, like, other times when they have been successful in doing math. And with this other student, you might think, well, all right, I'm going to try, I know that they're interested in history. Maybe I'll try and connect this example to some historical situation. I'll have them create a pedigree about, you know, the Russian royal family and the incidence of hemophilia or something like that within. So it's thinking about, you know, what are some ways that I can, A, understand what might be a motivational issue with my students, and B, you know, what can I do to kind of get over that hump? Because it's not always going to be the same strategy for these two students, even though they may look the same, right? And, you know, you guys may have sort of had that experience when you're doing, you know, teaching or training sessions yourselves, you know, when you sort of look out into the audience and you think, like, you know, there's all these kind of faces and you have no idea, you know, what people are thinking. You know, are they lost? Are they bored? Do they not want to be there? You know, there's all sorts of reasons that people can have those feelings, and it's sometimes difficult to know. All right, so we've sort of looked at this kind of end of this, right? Now we're going to we'll try something. So you need a paper and pen for this. Everyone have a paper and pen? Okay. All right, so just want you to look at this picture, that I'm going to show you. I'll just, like, I don't know, 5 seconds. Okay, so thinking about the picture, how many people were in it? If you know, write it down or make a guess. How about this? Like, what color were the curtains in that room? And there were 2 sugar molecules mentioned in the image. You remember those? Tim, this kind of gets to what we were talking about earlier. So, all right, I'm going to ask you, Sandy, did you get this? Did you get how many people were in the picture?
No, because I had to just plug in my computer, so I had only 1 second looking at this. I only remembered one person at all, but I remember there was one person. I didn't see the others at all.
Okay, and then we have these 2 sugars. Did anybody remember that?
Mm-hmm.
No? How about this?
One thing I did get.
Oh, you did? Which one, the curtains or the sugars?
The sugars, and then I made the curtains the color of that man's shirt.
Like the orange, is that the?
Yeah, I had orange as well.
Black.
Yeah, me too. I had like a dark red or something like this, but it's like the wall. Yeah.
Okay, so we're going to come back to this in a second. So let's look at something else. Okay, so now I'll give you a little setup for this next thing. So this is something about cells. So cells in a multicellular organism are connected to other cells, right? And on the next page, there's going to be a picture, and I want you to look at the picture and I want you to find the names of the 3 types of connections between animal cells, right? So cells being connected to each other, there are names for these connections, and there's 3 of them. So I just want you to look at this picture and I want you to think about that. And you can write it down or you just remember. Okay, so I'll ask you, Amanda. So what are the 3 types of connections between the cells?
Tight, gap, and I missed the other one because I was reading all the information about the other 2.
Okay. Tim, did you get them?
I don't know if I'm pronouncing it right, but desmonas with tight and gap.
Desmosome, I think. Yeah. Uh-huh. Hi, Marcy.
Hi, everybody. Pardon the delay. I just got off a call.
No worries. No worries. We'll jump you in. Just stay there for 1 second and then I'm just asking them a little question here. Okay, so Tim, you had desmosomes. Is that what you have? And
yes.
The first one?
Tight and gap. Tight junction and gap.
Okay.
Junction.
Right. So we had tight junction, we had desmosomes, and we had gap junctions. Now, what made that question or that task, let's say, different from the first one?
It was focused.
Focused. Is that what you said?
Yeah, it was really clearly a task given to, and when you look at the picture, I actually only looked at those 3 words and focused on writing them down.
Right. So you could essentially ignore all of this, right? Because I said to you, okay, all I want you to care about are the names of these things. And so you didn't need to pay attention to any of this. Amanda was trying to be like an overachiever. And
You're tricking me. So I was like, she's going to ask something about the rest of
it.
No. All of the rest of it.
But right, so all you needed to look at, as Sandy said, right, is this part, right? And so you could ignore all of that, right? So when we think about this, like, let's say you were having somebody, you were in a learning environment, and you wanted to have somebody watch a movie, and they were going to write an essay after the movie about, costumes and the time period or something like that, right? If you tell them that ahead of time, then they can purposefully focus their attention on those elements of the movie, right? And so they might not have as good of a memory of the plot or some of the other aspects of the movie, because you have told them ahead of time what you want them to pay attention to, right? And this goes back to, I think, what Tim was saying at the beginning, that when you have a whole bunch of information, right? If I tell you ahead of time, okay, the first diagram, you had no idea. You were just looking at it. You don't know what I'm going to, if I'm even going to ask you a question, right? You're just looking at it. There's a whole bunch of stuff. There's people, there's molecules and stuff down the other side. But So you have no idea. Whereas in the second situation, there's a targeted focused question that is helping you to kind of push all the other stuff out of your mind and only focus on the thing that I want you to focus on. But sometimes we forget to tell that, to do that step, right? And so if I have you watch the movie in that other example and don't tell you, okay, I want you to focus on the costume and the time period it's in, then at the end of it, it's kind of a crapshoot whether or not you'll remember any of that stuff, because everybody has different things that they might focus on. But if I tell you ahead of time, then you're much more likely to actually be able to do that and then succeed on some task that I give you. And I may ask you, okay, now I want you to watch a movie and I want you to focus on the themes, and you're going to compare the themes of the movie to this other movie that you've seen. Okay, so now you might not pay any attention to the costumes and the time period because you're focused on the themes and how you're going to compare it and contrast to some other situation. So I think that just this idea of thinking about how you can help people know and understand what it is that's important, right, in a big sea of information is a really critical component of that design. Let's look at another example here. So this is a study that a friend of mine did actually on fourth graders, right? So they were teaching students in fourth grade to start to use this, integer number line like this. And after several sessions using it, they said, okay, we want you to create one, right? So draw a number line. And if these aren't coming out particularly well, but so some students produce, kind of viable, reproductions of this. But what do you see? Like, what do you notice about some of these diagrams? Like, what's the student, let's say, I don't know, here, what's this person doing?
They flipped the negatives.
Okay. Yep. What about this one?
No demarcations.
Okay. Yeah, no demarcations, and also like very different like spaces in between, right? Like same thing here. Like, this is kind of big and little and little. And so what you see here is, again, that clearly when you have a number line, the size of the interval pieces is very important, right? As is the ordering is important, but the size of those pieces is important, particularly, when we start talking about fractions on number lines and things like that. But what we see with these students is that they're not seeing that structure and the relationship between this on this number line, even though they've used it for several days, right? And there's a couple of reasons why. One of them is that it's taking so much brain power, cognitive effort for them to even deal with positive and negative numbers, that they aren't devoting any cognitive resources to thinking about that numerical structure, right? That's not something that they're focused on. Just like when we learn to read, we have to focus on the individual letters that we're sort of sounding out, and we're lucky if we can actually figure out what the word is, let alone the meaning of the sentence or the meaning of the paragraph, right? Because we're really focused on the specific pieces. So the students here are doing the same thing. They're trying to work through this new process, and possibly also the instruction was not telling them like, hey, guess what? These gaps between these numbers are also really significant, right? But when we're first learning something, that can be okay as long as that next thing actually happens, right? But here we just see these students who are not sort of devoting as many resources to that because they're so busy and taking up their brains thinking about this new concept and new idea. So again, just an important thing for us to remember that when there are salient features of a particular situation like this, we'll have to remember to make that really explicit to students, because they probably won't pay attention to it if we don't tell them to. So this idea, right, that we've got our sensory memory and what we're paying attention to. And again, back to Tim's point, and Marcy, just to catch you up there, that earlier Tim was talking about how, when you have a bunch of information that you're presenting to somebody, how can you make sure that they're, taking from it what you want them to take from it? How can you make sure that they're paying attention to the right components and remembering as much as they can about those things? And this is just one way. I mean, there are lots of ways when we design a learning experience that we can do that, but we have to tell people what to pay attention to. And even just silly things like, using arrows like these, or, colors, or pointing to things, or highlighting things, that you can help people to sort of focus, so they're not equally looking at everything, trying to figure out, right, what they should be paying attention to. Because if they're doing that, then they don't have as many cognitive resources left over to do what you want them to do. And so this idea, right, that when we're learning, we need to know what to pay attention to and what we're supposed to be getting our brains to learn, right? And our learning design can help there. Any questions about any of that so far? Comments?
I love that. I found it really interesting with the scale. I thought like that was absolutely they're just as simple as like this picture says so much about how communication even happens, never mind learning.
Right.
When you're trying to teach somebody. So
Right.
it's really interesting.
Yeah.
Thank you very much. It was my highlight so far.
Well, great. Awesome. Hopefully there'll be another highlight.
Julia, let me ask
yes.
on the integer timeline. What do you think about, and pardon if we've covered this, but about touching like kind of multiple, I don't know, senses. It's not really senses, but like if you'd taken that timeline and where the spaces were put like apples, like here is like the width of an apple. So we have 1 apple, 2 apples, 3 apples, 4 apples, 5 apples, or like, and then maybe going the left way, they're like invisible, like you're a store and you hold more apples than you have. And it's kind of like the outline of apple, 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 like showing it's a unit or a thing. Like when you, like, what do you think of, I guess to me, that's about adding visual representation as one more layer of meaning. Like what do you think about that? Or does that get to be information overload, kind of like the first picture with all the cells where there's like a lot going on?
The answer to that is really, it depends, right, on where you're sort of meeting the particular people that you're teaching, right? So if it's the very, very first kind of exposure to, positive and negative numbers, you may want to approach it in one way, and you may not even start there. You may start with something else, but I think as quickly as possible, particularly because it's important, right, to add in some element that they understand, and it might be better to be something that's not a discrete object. And again, because when we think about numbers, it's good for people to kind of imagine that we've got this continuous thread, right? It's a sort of yes, we have these discrete things, but particularly when we start thinking about things like fractions, and it's very difficult for a lot of students to understand that a fraction is a number and not just a piece of a pie or a piece of a thing, right? Because oftentimes we use that model to teach fractions. So I might think maybe like a brick wall or something like that, where you could see that each brick, because you could kind of divide a brick like this into infinite, relatively speaking, right, like pieces. Whereas an apple, given that it's round like this, that could be confusing, right? But I think that idea of using, and again, when we think about teaching, it's always really great for us to have these multiple representations of a certain thing, so students don't get too attached to a certain model and certain features of it, because then they start thinking like, oh, okay, yeah, fractions are pieces of pizza or something, right? And then they can't see that a fraction could be on a number line, or a fraction could be a group of M&Ms or something like that, right? So yeah, I think it's all about, I think in some cases when you're first introducing things, trying to keep it as simple as possible, and then kind of adding some complexity to it, but also making sure, and we're going to talk a little bit about expertise in a minute, but also making sure that you don't forget to say, hey, by the way, don't forget, like here, the gaps between these things is an important thing, because when you have that expertise, you may think, oh yeah, everybody already knows that. Yeah, I get that. Yeah. But yeah, I think it's a good point. I mean, just again, thinking about ways that you can support that understanding is really important.
Got it.
And so one of the things that, we hear people talking about this a lot, which really connects to, again, this thinking about attention, right? And what we're paying attention to, and some of these things that can impede or get in the way of learning when we think about our sort of motivational diagram, is this idea of cognitive load, right? And so we've thought about this idea that anything that we're bringing into our brain has to be processed by our working memory. And the information that we can process in our working memory is small and finite, particularly when you're learning something new and you're a novice, right? And so if we have this cognitive overload and the amount of information that is coming in to our working memory is too big, then we can't process any new information. And we may not even be able to process the information that's in there because there's too much other stuff happening, right? And it's very, very common in novice learners. And it happens when too much stuff is coming in, there's too many interactive, I'm going to use the word element at the risk of being jargony, but like what we really mean by element is just in your working memory, we have these kind of things, we just discrete chunks of things. And if there's too many, and those are these elements that are of information, if there's too many of those and they're all kind of competing with each other and you don't know how they all interact and connect, then it's going to be a mess. You can't learn anything new. And you also see our judges earlier, right? You could be distracted by something else, right? You could be hungry, you could be stressed, you could have threats to your identity, you could have some strong emotions coming into play. All of these things can be barriers and impediments to you learning. And again, we think about, particularly the third thing, even if you've got a great learning experience or learning environment, if you're distracted by something else, it doesn't matter. And so we have this limited capacity, right? We've got 7 to 9 kind of things that can be in there. And I'm not going to go into this because this goes a little bit too, I think, getting too complex and technical for right now, but the chunks are really the sort of way that you're kind of organizing information. And we can have about 7 to 9 things in there. You can just think about that as you build expertise, you can still only get 7 to 9 chunks of information in your brain, but the chunk is bigger, right? But it's still only one, but it's bigger and more connected. And that's what it means when we develop expertise. And a really critical thing to think about when we think about learning is this idea of intrinsic cognitive load. So everyone always talks about cognitive load as being bad, right? It's like, oh my God, I'm so overloaded. Well, this has too much cognitive load. It's crazy. I'm overwhelmed. But anytime we're teaching somebody something, we need to have some cognitive load. Otherwise, they're not learning anything, right? There has to be some thing that you're taking in that is causing you to change what's in your brain and to move forward and learn something. And we call that the intrinsic, like sort of what's about you, cognitive load. So if you think about for any person, so let's say I take Marcy right now, for any person, individual at a given point in time, a certain problem that I could give her would be X difficulty, right? And it wouldn't change, right? I could give her a problem to do and I could give the same problem to Tim, and it might be really easy for Tim. It might be really difficult for Marcy. It might be really difficult for me, but that cannot change because that's just where I am right now with my state of my knowledge, right? So it might be, I might be able to juggle 2 balls, and if you said, okay, try and juggle 3, I'm like, okay, that will probably be a little bit easier for me than if I couldn't juggle any at all, right? If you said, hey, here, try and juggle 3 balls, that in and of itself is going to be more difficult for someone who can already do 2, or less difficult for someone who could do 2 than can do 0. So that element of the learning experience is something that you want, right? So you want there to be some amount of intrinsic cognitive load. Otherwise, whatever I'm trying to teach you, you already know it, or it's already too easy for you, right? You need to be like moving forward. So there has to be some thing that you're learning. And
Can I
then,
ask a question about that?
yeah.
Do you think some people have different overall capacity or overall levels of intrinsic cognitive load? Or do you think that that just depends on what it is that you're trying to teach?
Yeah, it just depends on what it is. Yeah. So it's really like basically like if you already have a bunch of prior knowledge and a bunch of prior experience in something, then how difficult you will find a particular task will depend on that, as well as this other stuff that we'll talk about in a second, the extraneous part. But, I can't alter how difficult it is for you sort of in and of itself. That's just fixed, right? It's however, if you've got a degree in mathematics and I'm giving you some math problem that is has a really low intrinsic cognitive load for you, then it won't really matter if you're in a super distracting environment, because you won't have maxed out your cognitive resources here, right? But if the thing is more difficult for you in and of itself, for you, the learner, which we'll look at in a second, and there is also some extraneous noise happening, then it's going to push you over the edge. So if we look here, like this, for any given person, if this intrinsic cognitive load is pretty low, so how difficult I find this thing is pretty low, even though there's kind of a lot of extraneous cognitive load happening here, I still have some available mental resources, right? Like that's represented in this green box. So I've kind of got extra, it doesn't matter. Like, so this is pretty simple. I've got enough resources, and the materials, so the extraneous cognitive load is caused by the materials and the environment. They're not going to have much impact on me. Does that make sense? Yeah.
That's helpful.
So then
I think some people think that, people are smarter or whatever, but it's really about the load is kind of what you're saying.
Right. So yeah, because any problem, it's sort of like when someone says to you, okay, if I said to you, okay, Amanda, write me a hard math problem. Like that's not really a reasonable question, right? Because what you then would say, well, hard for who, right? Like hard for a 5-year-old or hard for a PhD mathematician? Like who is it for? Because a math problem in and of itself can't be difficult. It has to be difficult for somebody, right? And that is what varies in these sort of learning experiences, is that I need to consider what type of intrinsic cognitive load is this task going to pose on you, the learner, right? So in this first case, it was kind of easy-ish, right? So that wasn't imposing that much intrinsic cognitive load. And so even though I had a decent amount of extraneous stuff happening, I had this extra space. It didn't really make any difference. In this second task now my intrinsic cognitive load of a second task that I'm giving you is much higher, right? It's almost twice as much as the first thing. And now if I have the same amount of extraneous cognitive load, I've maxed out of my mental resources, right? This was more difficult for me. And so this extraneous piece had much, much more of a negative impact on me. And I can't learn anything because I've exceeded my capacity, right? So given that we know that intrinsic cognitive load is fixed at any one time point, how could we solve this issue that's present in task 2? What can we do to our learning environment?
Make it easier for learning, so using simple to complex approach, maybe starting with something very simple and then put some extra on top.
Yeah, I mean, you could, there's certain things that you could do to what we call manage the intrinsic piece, right? We can't really reduce it because, again, it is what it is. You have your level of knowledge or expertise about juggling, and I can't really fix it, right? Like I can't do anything with that. But what I can do is I can reduce this part, right? I can reduce the extraneous piece to kind of, and again, we're using this kind of physical models to show this, but I could reduce that. So now I'm within the confines of my mental resources, right? So I've modified the materials to decrease that level. And now, even though the same problem or same task is exactly the same difficulty for you, now you can actually do it because I've removed some of this other noise.
And what's some examples of extraneous cognitive load?
Right. So right now, let's say, so I'm talking to you guys, I'm focused on that. And now all of a sudden, a second ago, my son comes in here to get something out of the printer and I'm distracted by that. Right. Or, there's a bunch of noise outside or my phone starts ringing, or I all of a sudden realize that, my parents have been fighting a lot and I'm worried about that. And it's just anything else that is coming into my brain that I'm sort of paying attention to that is taking up this room in my brain, right? And it could be, sometimes it has to do with, back to the earlier example of paying attention, that when I showed you that photo of like the Arrested Development, that was the cast of them, that it's like, well, there's a lot of stuff happening there and I haven't really told you what to look at. So you might be thinking, okay, I've got to really quickly look at all this, but I can't keep it all in there. But if I've told you what to look at, then you can ignore everything else, right? And so you don't have as much of that sort of competing stuff. Marcy, did you have a question?
I was just going to say that I think the middle image is really what we've been talking about so much during COVID, and particularly for women. I happen to work with women in leadership in that, I think the mental load, the cognitive load even of homeschooling kids and trying to figure out vaccines for elderly parents. And it's just like this soundtrack running in the back of one's mind of these extraneous things that have surged now. And hopefully are quieting a bit. But I think employers haven't been able to control for that.
Yeah, and it's just, I guess a simple way to put it is it's just anything that is occurring that is not sort of germane to what you want to do, right? That if you're trying to write a paper or do something that in the ideal universe, you're focusing all of your cognitive effort on that. But there's all these other things that can come in, like sort of day-to-day things like Marcy's talking about, or you're stressed about money, or you're stressed about this, or you're hungry, whatever it might be, that can then cause you to not be able to even engage in this part, because this is sort of pushed you over the edge of your kind of available resources. So I think just paying attention to that. And I think that the thing that we see that isn't always talked about is that, when we think about this intrinsic component, right, that's this difficulty or complexity of what you're actually doing relative to your goal, there are things that you can do to kind of support that, right? So if I'm teaching someone something new, I can, break it down into steps or pieces, right? Rather than just throwing everything at once. The task is still the same, but I'm trying to kind of, chunk it into pieces to help kind of manage that intrinsic cognitive load. Or when I'm introducing a new idea, I could, and we talked about this a little last time, I could use like a worked example. So then I say, okay, I'm using this worked example. I'm not going to have you solve the whole problem. I just want you to give me the first step. Or I want you to look through the steps that someone else has done, right? And then now you do another problem where you just do, the first 2 steps or something, right? And so all of these things are things that we can do to help kind of manage, right, or optimize how difficult somebody finds something, aside from all of the sort of extraneous things that can come into play.
Can you go back one?
To this or
previous? Yeah, I wanted to add on what Marcy was saying, or I don't know if I'm asking a question or if I'm just clarifying something or making an observation. I'll figure it out maybe when I start talking. But in terms of, I do, like with the COVID example, I think there were a lot of extraneous things, but the reason why I like this visual so much is that it shows that every person has a set of mental resources. And I think there's this myth floating out there, whether you're a student or an adult or wherever you're at, you are a human with a set of mental resources. And I think that there's this myth out there that we should all be able to handle more. So even like within COVID or within organizational changes or whatever it may be, if the intrinsic load can be managed as well. So in COVID, you're doing new on top of having a lot of extraneous demands. And so your intrinsic load is stretched.
Yeah.
because you have so many more processes that are working on top of each other. Plus your demands, just number of tasks wise, are stressed. And so maybe in a learning environment, if you're looking at one lesson or one class, there's not much you can do about that. But I think there's a lot, looking at a whole picture of like an organization or your life to be said about managing just setting expectations, because you make it so much worse for yourself when you expect that you should be able to add new on the intrinsic side, as well as new on the extraneous side, and then somehow just be a human that can handle much more than that.
Right. And I think what also I think is valuable here is thinking about how, even if you have, the two lower diagrams here, that the task in and of itself, right, has stayed the same, difficulty for you, but because you've reduced some of this other stuff, now you can actually do it, right? Whereas previously, you may, again, it could then cause you to think like, oh my God, I can't even do this thing. Like I can't even learn to juggle two balls or whatever it is, that because all this other stuff has gotten in the way of that, right? But if we can pay attention to that other component, reduce it as much as we possibly can in all these different ways, right? And here we're talking about instructional materials, but it could just as easily be, okay, you've got to offload some of this, familial responsibility to somebody else, or figure. And again, I'm not saying that's always easy, but it's even just having that recognition that there's a finite capacity. Stuff is difficult, if you're trying to focus on something, and you're never going to be able to do it if this other part is too big, right? And again, when we think about something like this, these sort of different strategies, and these are all ways that you can, again, take the same idea that you're trying to teach somebody, you're trying to train somebody on, whatever it might be, and think about, okay, given that its difficulty for you, Amanda, is the same, right? I can't change that, how sort of tough it is for you to learn this thing, but I can change the sort of way I'm presenting it, or the way I'm going to introduce it to you, or the way I'm going to help you to see it by doing some of these things, which can help that, right? Help you manage that. If I can help you see, this thing we're learning about today is exactly the same as this thing we learned about last week with this one change. And that's what oftentimes doesn't happen in instruction is people making some of these explicit connections to prior knowledge, or linking sort of abstract things to more concrete examples. But there are lots of things that we can do to help kind of manage that, as well as dealing with that extraneous part, right? So if we look at something like this, so, we've all seen a sign like this, and you look at this and you're like, oh my God, I have no idea, right? Like, what is this telling me? Like, when can I park here and when can I not? Like, I have no clue. And you're trying to put together like multiple sort of pieces of information, different days, some of it's overlapping, and it's crazy, right? But so what's a way that you could deal with that? Like, okay, completely change the organization and make it like put everything in one diagram, right? And if we look at this situation, like, what are some of the ways that this helps reduce that extraneous cognitive load? Like, what has happened here, like, compared to that other diagram? So we might say, okay, it's. Go ahead, Tim.
I was just going to say that everything's there in one place, so you can focus on the problem, which is to find out today if I'm going to be in violation.
Right. Yeah. So your problem to solve is it's Tuesday at 9 a.m. or something. All I want to know is, can I park here at Tuesday at 9 a.m.? So you can quickly look at this. Okay. Yeah, no. Right. But when you have this other situation, it's like there's too many things for you to kind of get into your head and kind of keep in there and kind of model and shift around, right? Whereas if you have something like this, we're very sort of focused on the user, their problem that they want to solve. We've got some visuals, You've got some like green is good, red is bad. And, you can pretty quickly see, when you can or cannot park here, right? So again, I think a really good example of a way that you can design something to help achieve a particular goal, right, that the user or the student or the learner of any kind has. And, why make them work so hard when you could do something like this?
Julia, can I add?
Yeah.
I think that this example, or an example like this, also points to helping other people mind map or visualize themselves. In other words, it's I can remember for some standardized test, the problems of a farmer has a field and wheat can't be planted next to rice.
Yeah.
Rice can't be planted next to corn every 3 years or something. And you'd be like, what? But if you started to draw the pictures and then put the rules. So my other takeaway from this is, as the facilitator, we could think about how do we present our information in a cleaner way. And then I think that the second takeaway for me is it would be cool to teach other people to break down their own complex problems using something like this. So mind mapping or whatever, we visualize or something. Because I think, especially at work, I think we're always faced with these complex issues. This client can't sign this unless it's got 60 days notice, unless that, unless this. So teaching people how to do this, I think, could be pretty powerful too.
Yeah. And there are lots of times, right, where, again, because we can't keep all that information in our head at the same time and also solve a problem with it, right? So it's not just that we need to put it in there. We need to be thinking like, oh, so this person wants that, and there was a dependency of this. But as soon as you've got a concrete model now, right, you've offloaded some of that, right, onto the paper, and now I can think about it, right? So you've just reduced that sort of extraneous piece, and you've now got more room that you can, okay, I don't need to keep writing this down. I already drew it. Now I can kind of manipulate and think about that, right? Yeah, it's a great point. So again, we can organize things, right, to deal with these elements that impose the intrinsic load, right, which is what we want to do. We want people to learn stuff. We don't want everything to be so easy that it's like, yeah, I already knew that, so I'm not doing anything. We want to maximize it, right? And so it's those strategies that we're thinking about there. All right, we're going to move it now into we've sort of talked about this, right, working memory. And now we want to think about, okay, how do we get stuff down to this other end, right? And the overall goal of learning, right, is developing expertise, building expertise. And this connects to something that Marcy was just saying. But, when we have expertise, we do things automatically, right? So when we think about learning to drive, when you first start, you're like, okay, I got to get in, I got to do the mirror, I've got to do the thing, I got to push this button, and then I can't forget to do the signal and all this, right? And all of these things very quickly are overwhelming because you don't have any experience with it, right? And as you develop your expertise and develop experience and get time behind the wheel and all that, some of these things, again, kind of smushed together, right? And now it's like, okay, you don't even realize that you got in the car, you turned it on, you did this, you do it all like without even thinking. And some of us can drive from point A to point B and not even remember that we did that, right? We've all done it, which is kind of scary. But as we do all these things, right, we start to be able to free up our working memory. And so now we can sing along to a song on the radio, or we can chit chat with our kids in the back seat or whatever. But as soon as we enter into a situation, right, where it's like something's weird, or maybe we get lost, or maybe, there's an accident over here or something, now we have to like turn off the radio, right, and stop the kids talking. And because now it's like, okay, hold on a second, I wasn't really focused on this, but now I need to focus on this, right? Now there's a weird traffic pattern here or something, right? So again, it's thinking about, how do we build up this expertise? And then what are these situations where then we have to kind of switch it back on, right? Switch back on our conscious kind of thinking. And if we think about experts and novices, when we're a novice, we have these kind of relatively like disconnected pieces of information and meaning and things that are in our brains, relatively disconnected. As we develop expertise, right, we start to kind of make these connections. We start to sort of form these things. We start to create a hierarchy. So now, as an expert, you're like, yeah, this is a new thing I'm learning, but actually it's just like this, and it also applies to this. And if I know about this, I can do this. And you start to kind of see things as much more interconnected. And just like when you're driving, the whole thing is kind of one big thing, right? You're not thinking about each element of driving individually. You're thinking about it, it's just one big, okay, I'm going to drive my car. I'm not going to think about the sort of discrete tasks that are involved, but a novice does. So I ask this, like, have you ever tried to teach someone something? And here, doesn't necessarily have to be in a classroom or a training context, but it could be one of your kids or something that you are expert at, and you've tried to teach it to someone else. And if you think about, how did you approach it? Was it more difficult than you thought? And what did you do? Like, how did you go about that? And anyone jump in if you have a thought.
So I don't teach. I think we all teach for a living in some way, but the struggles that I've had most are usually when people associate what I'm trying to say with something that has nothing to do with what I'm trying to say. And then it turns into this process of trying to back them up and like, that's not what I meant. So finding the right starting point instead of leaving it so open that people are making associations that are not helpful, and instead building off of an association that is helpful.
I was gonna say, I thought of an example of teaching my kids how to drive stick shift. And I had to stop and break it down into subatomic parts to put it together, because there's so many details about what's actually happening that you just ignore. As you were saying with your driving example, you just ignore that once you're doing it again. So you really, in my brain, I had to break it up so that I could teach it step by step.
Yeah. And was that difficult for you to do that?
I don't think it was, but it was like a pause to get prepared.
Yeah.
So it required better preparation on my part. It wasn't more difficult. It wasn't just step on the gas and let the clutch out, because there's more feeling behind all of those things. So I had to find ways to demonstrate that to them, that there's a touch to it.
Right. And I think that's a good example, right? So you're saying there's a feeling. And so, one way you could, and I'm not going to come up with a good analogy off the top of my head, but, you might think, okay, maybe they've done something else, right, in their life that you think is similar. So you might be like, okay, when you're, I don't know, driving a go-kart or something, and you do this is like that, right? And so if you can connect it to something that they already know, then they'll be like, oh, okay, I get it. I know how to do that. So now this is sort of like that, and so if you can think of those connections, can be one way to help people kind of get over that barrier. But it's difficult.
If I use the same metaphor, the same training type, I think it was, because it's a doing thing, it was important to let them fail at it without, and just say, well, what happened there?
Yeah.
When they dump the clutch, when there's not enough gas, the engine just kills, right? Or they pull up to the stop sign and they stay on the brake, but they don't put the clutch, engine kills. Okay, what happened there? Let's review that, rather than saying, you should have pushed.
But it's funny too. And it's funny too, right? Because I have this vivid memory of a boyfriend I had once who had a car, and he was trying to jump start it, or like, down a hill, like, and so I was in the car and he was pushing, I guess, or something. And then he would be like, pop the clutch. I'm like, I don't know what you're saying. Like, I don't know what that means. Right? And so like, here he is, like, he's like, well, clearly, and you just said a word like that too. Like that, it's like, well, I don't know what that means. But to him, it was second nature. Right.
Yeah, exactly.
I think tied to Tim's example, like to move it to the abstract. So, where I work, we're usually working more with leadership concepts. So they're more abstract, but in a way, it's the same. We might start with somebody doing some sort of admired leader exercise and thinking about how EQ shows up or how it impacts them. And it's like connecting to something that they've seen. But Tim, I liked what you said about failure. I mean, because sometimes, we could look at that even with an abstract concept. When was a time that somebody quit your team or you didn't have chemistry with them, or it's, you can look at the negative and, yeah, it's the same thing as with the clutch, but it's saying, well, I really blew it with this team member when I was focused on task and didn't whatever, But I think that the abstract, there's, even in teaching more abstract concepts, there's still these pieces, like what Tim was saying. I like, you used a word like microatomic
Yeah.
thing,
Subatomic.
Uh-huh. Yeah.
subatomic.
Particles.
And that, I think, gets to this idea that, that we talk about this expert blind spot, right? So when we think we have mastery, that we're not necessarily the best people to teach someone new, right? So there's me one time trying to teach one of my kids how to ski. I'm a decent skier, I've been skiing a long time, but I don't know anything about teaching people how to ski, right? And so my own expertise does not at all translate to my being able to help this novice person ski. And I learned that to my detriment. But it's this idea that when we have, we can look at this kind of trajectory when we're first kind of, a novice or something, we have this kind of unconscious incompetence. Then we start to know what we don't know. And then we start to know what we do know. And then we start to forget what we know. And that's the danger zone, like right here, right? When we're talking about teaching people things. And, it's like, why is it so hard for you just to do this thing? That we underestimate the time and energy needed for people to do things and to understand things. And really, really important when we're teaching anyone anything. And Amanda, it reminds me of some of those conversations, that we've had. And I think something you just said earlier about how, it's like just even kind of getting people to get one thing might take much more time than you actually imagine it might, right? Because you have this tremendous level of expertise, and it's difficult sometimes to kind of meet people where they are. And what we see there is, with students, that they can miss important things, they make mistakes and function sort of somewhat inefficiently. And it can ultimately impact their motivation, right? Because they might not grasp kind of how, when, why. Back to Tim's thing, it's like, okay, you screwed up there. Like, why? Like, what happened? Because if you can actually get them to think about it and reflect, right, on that and why their sort of part of this procedure didn't work, then they're much more likely to learn from that and, kind of keep going. Whereas if they just get kind of slapped on the knuckles and try again, then it's like, well, then you haven't learned anything from that experience. And so when we're experts, and it can really help to, Tim said this again, subatomic particles, right? Like unpack these tasks and what we call oftentimes this cognitive task analysis, where you can, and oftentimes it helps to sort of sit down with someone who's less expert than yourself, try and tell them something and figure out what questions are they asking you? What are you glossing over? What are you assuming that they already know that they don't? And that can help you then to think, okay, I was kind of glossing over this idea, but it turns out, people don't know that, or, so I need to go even more subatomic than that, right? I really need to unpack that. But anytime we're teaching people things, we really need to be thinking about this, because it's so easy to fall into this trap of, we have this level of expertise, and, sometimes we forget that other people that we're trying to teach don't have it. I feel like we should maybe stop there. I don't know if you guys have any questions. These conversations are always so fun and rich and interesting. I mean, we can carry on a few more minutes, but I don't want to take up people's time. We may have to have a part 3.
Thanks for all the info, Julia. This is awesome.
Thank you. Well, thanks so much for coming. I don't know, do you guys have any questions, thoughts, I don't know, musings that have sort of been unearthed in what we've talked about today?
I find it very interesting. I'm just like, you know, over time you learn so much and you become, maybe you don't even think you are an expert. I love this concept on unconscious competence.
Mhm.
You might be super competent, but you forget that you are. And then you're thinking like, oh, everybody, the whole world knows what I know because that's what my experience is, right?
Right.
So it's kind of going back and saying like, okay, so how did I get to that knowledge and how would I be going to teach it, even though if I don't consider myself being an expert? So kind of becoming a little bit more conscious about, again, of the competent stuff. So that's very interesting. But probably how, like what I'm trying to figure out, how can we identify where we are having this unconscious competence? And one of the topics that you were just saying, Julia, was the getting somebody less of an expert in the same thing to ask questions about it. So it's kind of being a bit more aware what other people, when they make a look, you know, when you don't understand something and they make, what she's talking about, type of thing. So to kind of just try to observe that and kick in and see what questions do you have, you know? Yeah,
I think sometimes, and I think sometimes when you have kids, it's helpful because, you know, I don't know like about others, but I know my kids are always asking things like, you know, I don't know, what's a mortgage or something like that, you know, like these questions that then it's like, oh, wow, like to really explain that. And you have to, and I feel like there's so many sort of things that then you have to explain along the way. And it kind of can be a good exercise, that type of thing, right? Because every time you come to a new thing, you're like, saying something about a loan or something, then they're like, well, what's that mean? And then you've got to go backwards even more, you know? And so it's just, again, thinking about anytime you enter into a new sort of teaching and learning experience, a really key factor is like, where is the person right now in terms of what they understand, right? Are they a complete novice? Do they have some level of understanding? And that's why, I mean, teaching can be so complex, right? Because you have so many different, you know, individuals who may have different levels of experience and current knowledge, and you have to sort of try and figure that out and kind of meet people, you know, where they are, and can just be a big challenge, or both in a teaching and a training type environment, because you want people to get the most out of it that they can, you know, and that's difficult because not everyone is coming from the same place.
Yeah. Would you use some pre-training questionnaires to make sure that the stage the learners are in a similar space, so for them to get the best out of it? Or
sometimes I'll do that. Yeah. I mean, I think it depends, you know, like something like this, right, like is also somewhat of a challenge because I don't really know how much people know and don't know. So I'm kind of just starting at a kind of more basic foundational level, and some things people may have more existing knowledge on. But yeah, I think if when I do, I mean, if I did something that was, I'll do trainings with curriculum developers and things sometimes, and there I'll try and get a sort of baseline level of knowledge for myself about where they are and kind of, you know, kind of some of that stuff, just so then it feels more efficient for them. Yeah. All right, I can't see everyone. I don't know if anyone else is still there, but let me see. Maybe I'll stop my recording. How do I do that?